I would love to present you Roy Williams. He is a software engineer at Lyft. He's focused on developer infrastructure for the past 13 years. Worked at a lot of great companies, Microsoft, Google, Facebook, right? And Lyft now.
Yep.
And he's going to speak to us about the ride to Python free.
Cool. Yeah, well, thanks for having me. I know the ride to Python free wasn't the name of the talk, but I thought of it this morning. I thought it was too good to not actually use. But yeah, so thanks. My name is Roy. I've been at Lyft for about 2.5 years now. But pretty much my entire career, I've worked on developer productivity, making sure that our developers have the best tools to get everything done that they need to get done. And make sure that the latest and greatest version of Python is a big part of that. So quick show of hands, who here has heard of Lyft? Okay, that's like almost everybody. But for those of you who don't know what Lyft is, our mission is to improve people's lives through the world's best transportation. Now, what's kind of interesting here as it pertains to porting to Python 3 is that we see ourselves as a transportation company. Technology is a means to an end, and by all means, a very complicated means to that end, right? Involving self-driving cars and incredible amounts of machine learning. But at its core, we are a transportation company. We want to help people get from A to B in the most efficient way possible. We'll come back to kind of how that impacted our process here. But we're going to go over how we Python at Lyft, the process we actually take to do the upgrade. This is going to be mostly inside of Jupyter notebooks and code, how we spread throughout the organization, and some future work that we're going to continue working on. So a quick show of hands, who here is still running Python 2 in production? Probably like half the people. Who here would like to not be running Python 2 in production? The same number of people, it's great. Cool. So first, a quick bit about Python at Lyft. So who here saw the 2017 keynote at PyCon about the mosaic that is Python? Jake did a great job of talking about stuff way too smart for me to understand about how to use Python for astronomy. But how Python is this mosaic where you have data science and astronomers on top of that, and people building web servers and websites like Instagram and Pinterest on one hand, and then people doing config management with Ansible and Salt. And one of the other things I think is really interesting at Lyft is that we actually pretty much use the entire mosaic. It's not super uncommon for us to have services that are configured by Salt, which is all written in Python, running a web server, running Flask, serving data built with scikit-learn, and maybe manipulated with Pandas. And this is just pretty much common for us. Our stack is pretty normal. We run Flask as our web server, Gevent we use for cooperative multitasking, which is similar to Twisted for asynchronous programming. Gunicorn is our Wishy server. And if you haven't heard of Envoy is another open source project out of Lyft. It is a networking solution that I won't go too deep into, but very optimized for microservices. Highly recommend you check it out. Really cool stuff. But the other thing to note here, the whole motivation for building Envoy is that we have a ton of microservices. So if you saw the Instagram talk, they were focused on, they had one big code base. They could have Lukash and a few people sit in a corner and port for 7 months and emerge with Python 3. We have hundreds of microservices, so we can't really do that. And then the other big portion for Python at Lyft is our data science component. This is the people who are, again, way smarter than me, but they are using NumPy and SciPy, Sklearn, Pandas, the normal stack, with more PyTorch and TensorFlow coming in as you start doing more machine learning and AI. Yeah, so I won't go too deep into why we decided to stick with Python 3 instead of, say, porting to something else, because we're at the meetup and everyone knows how great Python is. But we're going to dig into how we actually got this done. As you mentioned, we have a bunch of microservices. So we had to create a repeatable process that each one of these services could undertake. They're focused on their core product, though. Like maybe they're trying to fight fraud or compute pricing or better match drivers to passengers to increase the overall efficiency of the system. They don't care about porting to Python 3, and nor should they. And so we really tried to make it as painless as possible and really backgroundable as possible. So we broke it up into digestible chunks that you could do while you're waiting for a build or while you're blocked on a decision, and you kind of move the crank a little bit. But before we went down that path, we kind of iterated on this process on a number of services until we felt like it was ready to open up to the world. So now we're going to dig into kind of how all that works mostly with code. So step one, as Craig talked about, is updating dependencies. Now, maybe 2 years ago, this would have been a blocker. You would have tried to upgrade Gevent, and it would have only supported Python 2, and you said, well, that's that, or Twisted, and just given up. Now, most things actually support Python 3. It's really not a big deal. You can use pip tools or piprod or whatever else to automatically update your dependencies. One of the things we found, though, is that it actually did help us emerge with better code. This is kind of my favorite example of this. If you're familiar with the mock framework, maybe you're writing some code, you want to write a test case that asserts some method was called, and you see on Google that there is an assert called method. So that's super cool. You write a test case like this and use assert call, but this is like what that should have thrown, right? Like we didn't call bar. Why did assert called not throw? And it turns out in mock 1.0, there is no assert called method. So all we did was get back another mock. And just changing kernels over to Python 3, which is mock 2, this immediately throws. And it says bar, expected bar to have been called. It's even more fun than that. It will throw on any method that starts with assert. So if I do assert cal, I get an attribute error. Interestingly, also, asret. I'm not quite sure how they decided asret and not any other mutations, but anyway, here we are. But so as we started upgrading our dependencies, we realized we had thousands of test cases that did nothing. They would use these helper methods like assert called, assert not called, that did not exist in the library. And so we just went with better code, even just by pushing through dependency upgrades. So cool. So now we have our dependencies upgraded. The next step that we undertake is static analysis. So there's two main tools that we use here for static analysis, PyLint and Python Modernize. We'll start with Python Modernize. Python Modernize is a tool based on lib 2 to 3 that instead of porting your code from 2 to 3, it ports it from 2 to 6, or from 2 to 2n3. So we have a kind of contrived code base here. I'm doing some bad stuff. Who knows what's going on here? It's probably not the worst code people here have seen. So I have a method ras and a method foo. And I have a test, but it only tests ras. So, oh well, what are we going to do? But we run the tests, and the tests work. So Python Modernize will go through and refactor your code using the same tools as 2 to 3. Now, 2 to 3 has its issues. For example, if you assign print to a function, it blows up. But it's kind of the best tool that we have and gets you maybe 50% the way there. So Modernize has fixed a few things. It's imported absolute import. It's dealt with the print function that Craig brought up. It's changed even small things like max int doesn't exist anymore on sys in Python 3. It's now max size. And it's changed all of my iteritems to 6.iteritems. And so this, developers really appreciate this because these are like very kind of mundane things that they don't want to have to deal with, that don't use all of their intelligence as a developer, can now be done automatically for them. And generally we find that we don't have any false positives or breakages through Modernize. One of the other things that we've done that I think was really useful was we made this part of CI. And so if you opt into Modernize, should you put up a pull request and it needs to change anything with Modernize, your PR fails. And it says, here's what you need to change, really powerful. So going back to our code, great, looks good. Fix some things here, cool. So now we're gonna run PyLint. So who here has used PyLint? Know what PyLint is? It's a great static analysis tool. It also has a flag --py3k that will find Python 3 compatibility issues. We've also contributed a bunch back to this. Now the things that you find here are things that are either really hard to come up with a correct answer for statically, or things that we just haven't gotten around to backporting to or porting to Modernize. So it's flagged two things here. Division has changed in Python 3. If you don't know what's happened here, in Python 3, division is always a float, whereas in Python 2, if both were an integer, it would return an integer. So I have to understand here whether or not I wanted an integer or I wanted a float. And so in this case, I do want an integer, so I switch it to the floor division operator. Additionally, exception.message is gone. So I have to change this to stir. Rerun PyLint, everything's fine now. And again, these are tools. This will maybe just 70% the way there. It'll find the lion's share of really simple things. And developers can now focus on the things that matter and not like things that are mundane and should have been caught ahead of time. Cool, test still pass, we're good to go. Next, I want to talk a bit about dynamic analysis. Now, dynamic analysis is watching your code run and observing things that could possibly be bad with it. Now, Python has affordances in both Python 2 and Python 3 for dynamic analysis. The -3 flag in Python 2, the BB flag in Python 3. So let's run our test with the -3 flag. So we see we get a bunch of warnings here from completely unrelated code. I've actually gone through and tried to patch some of these. They haven't always released all the fixes. But we also get an error in our code that we are comparing unequal types, which is not supported in Python 3. So looking at the code, we are comparing value, which is an integer, to limit, which is none. In Python 3, you can't do this. So that's why we had that failure here. And so the -3 flag is really valuable to integrate with your test. But as you see here, we just got it as a warning. So maybe I want my test to actually fail. We use PyTest at Lyft. And so what we do here is we use conf test. Now, as you saw, you can't just enable it everywhere because a lot of third-party code isn't -3 clean. And so we just, in our conf test, will enable deprecation warnings on the module under test. So before, we weren't actually enabling this. Now, let's enable it. And our tests fail. And we get the deprecation warning treated as an exception. So let's go ahead and fix that. This may not be the right fix, but who knows? So now we are always comparing integers to integers. And great, we're clean, awesome. So the next step is to run tests in Python 3. So let's go ahead and do that. But the tests fail here, which is super weird. So in Python 2, we always went down this branch. But in Python 3, we're winding up here. I wonder what's going on here. So Python 3 usefully has the -bb flag, which I highly recommend even you run in any Python 3 code base. So -bb will emit bytes warnings. So anytime you're doing something like comparing bytes to strings, it will throw an exception and say, don't do that. So let's run under the -bb flag. And sure enough, I am comparing bytes to a string. Some value is bytes, and I'm comparing it to true. Let's fix that. And hey, my test passed. If you watch the Instagram keynote, they brought this up as one of the last things for one of the last blockers for porting to Python 3. They should have been using the -bb flag because they would have caught it ahead of time. Cool. So now we've kind of gone as far as we can go in Python 3. So now it's time to run our tests in Python 2. Now it's time to run our tests in Python 3. We had our contrived example. But I want to dig into some of the kind of more fun differences that we've seen in Python 3. And this first one is the one that really messes the most people up. They don't understand what's going on here. So question for you today, data science, how does rounding work?
Good question, I have no clue.
Okay, so what should 1.5 round, or so what should 0.05 round to?
555. I don't know. 0.
1. Yeah, you learned round halves up, right? And that's what Python 2 does. Oh, shoot. No, I gave the game away. Shh. Ignore that. OK, cool. So Python 2, we're back. 0.5 rounds to 1, 1.5 rounds to 2. Everything is good with the world. But there's a problem with this, in that it introduces upward skew. So this is like a contrived example where we generate 1 million values, all of which are 0.5, and we compare the real mean to the rounded mean. And there's 9% error. It's crazy, because every one of those values is getting rounded up. The actual mean is 4.9, is 5.49. The rounded mean is 5.99. Bad stuff. So in Python 3, it follows a rule called banker's rounding. So banker's rounding is round towards nearest even. So 0.5 goes to 0, 1.5 goes to 2, 2.5 also goes to 2. Now, if we do this, we get much less skew, around 10x less skew. And in the real world, it's actually more like a 1% skew upwards. Being a company who worries about data science, this is really important to us. This is one of the things that freaks out people the most, because you learn how to round in like 3rd grade, and then you learn that it's wrong, and you're like, everything is a lie. Like, did Columbus even come to America? So one of the slides that I missed here, so one of the things that we actually just open sourced a few hours ago is a library we lovingly call 6 with a Y, which has some compatibility functions in there that we find useful and we use at Lyft. It's only 4 functions so far, but we wanted to iterate on it faster than the stability needed for something like 6 proper. So going back to our fun differences slide, we can, under Python 2, just run from 6 import round. And we're still running under Python 2, but we get the same Python 3 behavior. And we have the 10x less error. So a few helpful functions here. Don't be too freaked out by rounding. To be honest, it does not matter in practice, but it really freaks people out. Next problem we see in tests is has-adder. Some people say has-adder is considered harmful. So in Python 2, if you use has-adder, and the attribute is a property, and that property throws an exception. It just returns false. Now, Lyft has had bugs in production caused by this. And this behavior is insane. That's not what should happen. And of course, in Python 3, if you throw an exception as part of accessing the attribute, has-adder will also throw. Similarly, 6 has a has-adder function that backports the Python 2 behavior to Python 3. Two more fun things that we hit in a lot of our test cases as we were porting Python 3. Equality and hash, they really should be buddies for life. Python 2 lets you implement just equality without implementing hash. If you ever worked in Java, you know you should always implement the two together. And this is really problematic. You can wind up with weird code like this, where we have a class thing only implements equality, and we have a list of things that has thing 1 and thing 2, a set of things that has thing 1 and thing 2 in it. But thing 1 is in the list of things, but is not in the set of things. And like that is crazy making. Like, what do you mean that it's in the list but not in the set? They contain the same things, but the hash is different. So you don't find it. And in Python 3, it throws immediately. Thing is no longer hashable because it only implements equality. If I went ahead and implemented hash, then all is right with the world. Another kind of nuance that we've noticed in Python 3. And kind of lastly, I want to talk about comparisons. Oops, let me set that back. So we have an array X that has elements 1, 2, 3. And we say if X is greater than 0, everything's OK. And we go back to Python 2. And sure enough, in Python 2, everything is OK. And like maybe you're thinking, OK, maybe is it coercing and comparing the lengths? But if I change this to if it's over 9,000, it still says everything is OK. And there's definitely not 9,000 elements in that list. And it turns out what's happening is that Python 2 is falling back to memory location. And for whatever reason, all arrays have a higher memory location than all integers. And so, sure, like every array is bigger than every integer. And this is, again, crazy. This makes no sense. When you switch to Python 3, this immediately throws. Now, where we actually saw this most in practice is actually in the context of mocks. So with mocks, say you create a magic mock for foo. And you just create the foo, you pass it into a function, and that function says if foo.bar is greater than 0, print my test works. Now in Python 3, this will throw because you can't compare a magic mock to an integer. There is no comparison between the two. So to actually fix your test case, you have to go through and say foo.bar equals 10. Now your tests work again. So these are some of the most common issues that we hit. You may hit different issues as you're porting in Python 3. But so now we've got our tests passing in Python 3. And so next is time for deployment. And the single most common issue we hit at deployment time was bytes versus strings. So this would be very common. We have a function that would want to base 64 some value and return it. So we base 64 encode hello world and get back a string. And in Python 3, this blows up immediately. Because you can't base 64 a string, you can only base 64 encode bytes. And we hit lots of issues like this. Like maybe we read something out of a database, or we got something off the wire, and in Python 2 it was OK, but in Python 3 it's blowing up. So 6 also has two more helpful methods, ensure bytes and ensure string, with the shorthand B and S. So we use B to ensure something is bytes. So the value passed into B, if it's not currently bytes, will be encoded with UTF-8 encoding by default. And so if we do that, we get back bytes, and S does the opposite. Given it takes in either bytes or a string, and if the input is bytes, converts it to a string. And of course, like every time we have one of these, it's generally a bug. We should know whether or not we have bytes or strings, but like we want to continue making forward momentum. And as we talked about, one of the things we wanted to do was minimize the amount of churn that developers have to do. So that we use this to preserve the current behavior inside of Python 2. Cool. So once we went, I won't go too much into the wins once we deployed. Generally, there wasn't a huge CPU win, but we had around a 25 to 40% reduction in memory usage, which was great. Once we fixed all the bytes issues, generally deploys went fairly smoothly. We haven't really seen anything since. The kind of last thing I want to talk about here is how we spread throughout the organization. So we can do this for one team, and it takes me about 2 weeks to port a service. But I could spend the next N number of years porting services to Python 3. So we really needed to get uptake of this process throughout the organization. And so the few keys that we had here were, one, making this backgroundable and small. So when we go and approach somebody, it wouldn't be like, hey, set aside 2 months support to Python 3. You won't get anything else done. So just do modernize. Like just add in Pylon. Like it's going to be fine. And then make sure your dependencies are up to date. But it being in small digestible chunks made that conversation much more approachable than if it were like, here's this massive 7-month-long project. One of the other big things that we did here is that we really heavily contributed to Pylon and modernize. So whenever we finished porting a service, if there were any problems that we found that weren't found with Pylon or modernize, but really should have been, we contributed a fixer to Pylon or modernize. And now this in turn made it sure that every time you ported a service, it was easier to port the next service. And so that kind of helped us get some momentum going. And kind of lastly, this then led into what we think of like our strategy around snowballs and virality. So if you ever played the game Plague Inc., it's a hilarious game, but you play a virus and you're trying to take over the world. Now one of the key strategies for Plague Inc. is that you want to get your virus into a bunch of different parts of the world very early on so you can continue spreading. And we kind of thought about this somewhat similarly with Python 3 porting. We would go and port services in different parts of the organization to help build up knowledge inside of that organization, so then it would continue growing and continue spreading. Whereas if we just focused on one part of the org, the viral factor would have been smaller. And then this helped us snowball. So as we would go through and we'd port a given service, we would sit there, pair with people, they get really excited about it, and then they would help us port other services. So as we mentioned, every service got easier because we'd make the tools better. But then we'd also have more advocates and more people saying like, yes, you should do this. And so it wasn't just me saying like, here's all the things you need to do to port to Python 3. We had dozens of people around the organization helping us out. And this is what really helped us scale through the microservices. We really had to approach this as if we were a virus trying to spread. A terrible analogy, but the best one I can come up with. Cool. So where are we at right now? Our journey's definitely not over. We have around 20% of our services running Python 3, but they are some of the most important services. So if you open up your Lyft app and call a car, you are almost certainly hitting a Python 3 service somewhere down the line. New services now default to Python 3. We've had broad adoption of types via NumPy. We have some services that have gone as far as requiring every function to become types. As we've mentioned, it's about 25 to 40% reduction in memory consumption. And we've gotten the process to the point where it takes only around 2 weeks to port any given service. And that's really, really what's important here is that, again, if it was months, no one would listen to us. They'd say, I'm never going to do this. And we'd be thinking about how do we get 2.8 running. 2 weeks was tractable. We've even gone as far as to give people the ROI guarantee, where if it takes you more than 2 weeks of effort using the documentation and all of the tools, then I will personally come in and help finish your service, get your service over the line. I haven't had to actually do that, but that guarantee has helped teams actually take it on. It's almost like the FDIC, that I've backstopped how much time they're going to lose. Cool. So final thoughts, we kind of covered everything here. The automated tool, if you've tried to port to Python 3 a few years ago, it's way different now. The automated tools are way better than they were years ago. Most of the dependencies support Python 3. It's totally different. If you have microservices like we do, try to break it down to small digestible bytes. You're going to have to sell this thing. You have to think about how am I going to get the rest of the organization excited about this? And that's where we rely on snowballs and network effects. So if you want to email me, my email is rwilliams@lyft.com. Yeah, so with that, I'll open up to any questions.
Any questions in the audience?
Yeah.
So my question is, do you recommend supporting a single code base that supports both Python 2.6 and 3 at the same time?
So we do really try to minimize the amount of time that teams spend in like the 6 phase, because everyone hates the 6 phase. Like you have to kind of contort your code, but for no real gain. So one of the things I actually didn't put in the future work, we want to create a burn the bridges fixer that effectively goes through, removes 6, removes future imports, does everything to your code base, is purely Python 3. So yeah, so for the most part, we're building services. So once you're on Python 3, you don't need to worry about Python 2. Most services stay in the 2 to 3 phase, maybe a week or 2. Yeah.
Thanks for the talk. Can you just explain how you did the rollout of the runtime?
Yeah. So we use Salt to manage our hosts. So services would have to opt in to installing Python 3.6. One of the things I didn't put in here that was an interesting blocker was that if you say you run Ubuntu or something like that, a lot of the third-party PPAs don't have an optimized version of Python 3.6. So we actually wound up compiling our own so we could run with PGO, and we're not able to get LTO working, but most people don't run with LTO, so it's not a huge deal. But that's like a 10 to 25% memory or CPU reduction. So that was really important to us. Yeah, so services would just opt into it. We would generally canary for 2 or 3 days and then cut over production. Yeah. So at first we would just roll out to one box, and we would be physically watching the logs of that box in real time. And then the second there was an exception, we would turn off the box. So like I mentioned, we use Envoy for service-to-service communication. So it's fairly easy in Envoy to say kill it, and then no one else will talk to it again. Yeah, and so then we would go fix the issue. Most of our services will retry, so it's not a huge deal if one canary host is 500ing. Yeah, and so that would be kind of an arduous process. We also have a staging environment which we could use to cache most of the issues as well. Yeah.
Going from 2 to 3, did you have any kind of bugs that came up in the context of maybe I'm not quite clear what is the role of Gevent in Python 3, given that the language itself now supports asynchronous stuff. So did you have any bugs that were like an IO related bug that things behave differently? And that's both for synchronous and asynchronous context.
Yeah, so Gevent in 1.1 started supporting Python 3, and we hadn't really had any problems with Gevent. We had one service where there was a place they were clearly leaking file handles, and in Python 2 it was fine, and in Python 3 it surfaced the file handle leak. But that was really the only one that we saw when it came to I/O. Really nothing else came up for I/O. Eventually we will pursue async I/O, but for now Gevent kind of works well enough.
Did you have to change any of the Gevent code?
No. Oh. The question was if we had to change any Gevent code, and the answer is no.
Any other want to ask a question? All right, let's give another round of applause.
Thank you.